Very good morning to all of you. Dear student, today we'll discuss about the chapter 1 in class 9 standard. The chapter 1 is the matter in our surrounding. So let's start. You see, in our surrounding, everything we see that contains a matter, and all of you know the matter are different types that we know. What is called matter, that I will tell you. For the timing I am telling you shortly. Matter is anything which occupies space, has mass, and is perceived by our senses, or we feel. That is called matter. That means anything which occupies space, has mass, and perceived by our senses is called matter. Now today we will discuss about this matter. Let's start. You see, what are the contents today I will cover, I will try to cover. So first I will give you the introduction already given. Okay. Matter and its classification, characteristics of matter. Then states of matter, effect of change of pressure and temperatures. So what happens if you change the pressure, if you change the temperatures of the matter? So this is our objective to discuss today. Now, early Indian philosophers and ancient Greek philosophers classified matter in the form of 5 basic elements, that is called Panchotattva. We can understand Panchotattva, that means air, earth, fire, sky and water. Okay. So this is called Panchotattva. That is the old concept. Now you know the all livings and non-living things are made up of these 5 basic elements. Okay. So that is the idea. Now what is called matter? If you are asked define matter or what is called matter, then we can say anything which occupies space, has mass and hence weight, and is perceived by our senses is called matter. How many senses we have? We have 5 sense organs that we know. What are the 5 sense organs that you know? Eyes, nose, okay. Eyes, nose, tell me what else? Okay. Eyes, nose, tongue, skin and ears. That you know 5 sense organs we have. Now, what are the different types of matter? You see, different types of matter that will classify. I will give a map, mind map or the flow of chart, so that I will tell you details. So, solid also one kind of matter. Physical classification of matter. Liquid, solid example wood, okay, books, chair, whatever you see surround us solid. Liquid is water, alcohol, okay, petrol, that is liquid, gas, oxygen, air contains oxygen, nitrogens, okay, that is gas. Plasma is the 4th state of matter. We will discuss later on details. Plasma. One example of plasma, that is the fire or matter present in the sun, that is the plasma. And BEC. BEC is very important part, that is the 5th state of matter, is called Bose-Einstein condensate. Okay, that is discovered by the Indian scientist Satyendra Bose and with the concept of the Einstein's concept. Okay, and in 1995 the American scientists, they have discovered it actually, okay, with the help of the idea of Satyendra Bose and Einstein's. That is example is liquid crystals, that is the digit we write or we see in the computer and the calculator. Okay. Apart from this, we will discuss about that is the one more part, fermionic, that I will tell you. Fermionic condensate. Anyway, so if I see the flow chart of the matter, so this is very important and very useful to remember all this concept of the matter. Okay. So this first classification of the matter, you see the characteristics of particles of matters, diffusion and Brownian movement. I'll discuss later on. Diffusion and Brownian movement, different states of matter that I already told you: solid, liquid, gas, plasma, Bose-Einstein condensate, liquid crystal, and fermionic condensates. Okay. So, and then we have the interconversion of matter. That means how we can interconvert from one state of matter to another states. The process are called, if you convert solid to liquid, that is called melting; freezing liquid to solid, that is called freezing; boiling liquid to vaporizations with the help of heat, boiling; condensation means gas when cooled down, okay, that is the condensations; sublimation means conversion of solid to vapor directly without converting the intermediate liquid state, and vice versa. Okay, vice versa, we can say the depositions, and sublimation is conversion of solid to vaporization without changing the liquid state, that is the sublimation. Okay, so this part is very, very important. Now, what are the characteristics of particles of matter? Okay, so later on I'll come this side. Characteristics of particles of matters. We know we'll discuss solid particles, liquid particles, and gaseous particles. Solid particles or molecules are closely packed, most closely packed, and they have the intermolecular force of attraction is the highest as the distance is the least, and they have the intermolecular force of attraction is the highest and intermolecular distance is the least. Liquid molecules, you see, they have the comparatively more distance than the solid, and force is less in compared to the solid, but more than the gas. And gas will find the highest intermolecular force of attraction and intermolecular distance, highest intermolecular distance, and force of attraction is the least, because molecules are far apart, solid, liquid, and gas. Now, diffusion and Brownian movement. Diffusion means when you suppose, when you put a ink in a glass of water, that means ink, blue ink distributed to whole glass of water. That is the diffusions. Okay, so diffusion means molecules movement from higher concentration to lower concentration. That is the diffusion. That is the diffusions. And Brownian movement. What is the Brownian movement? Actually, liquid particles, whether the particles are continuously moving or not, that you can understand. So by, you can take a glass of water, okay, and you see the China rose, that pollen grain, yellow part, okay, will find that pollen grains, if you just put in a glass of water, and will find the pollen grains coming down and up, coming up, coming down and coming up. That means liquid molecules are continuously moving, okay, and that movement is called the Brownian movement. That movement is called the Brownian movement. Okay, so we have understood the characteristics of the particles of the matter. I'll discuss about the details with the diagram. Diffusions and Brownian movement I have discussed. What is diffusion? I have told you, molecules when movement occurs from higher concentration to lower concentration. Like if you smell, if we just spray that is the perfumes, we can smell it, okay, because molecules from higher concentration moves to lower concentration, and that is the diffusions. Okay, I have given another example. If you put a ink in water, in a glass of water, ink distributed uniformly to the glass of water, that means molecules movement occurs from higher concentration to lower concentrations. Then Brownian movement, I told you the example, okay, actually liquid molecules continuously moving. There are small light particles of China rose, that is the pollen grains, if you give, so that will coming up and down. That means liquid molecules are continuously moving. Okay, that is the Brownian movement. Then different states of matter I have told you, the solid state, liquid state, gaseous state, and plasma, Bose-Einstein condensate, and fermionic condensate. Then interconversion of states of matter, melting, freezing, boiling, condensation, and sublimation. That will come later on details. Now next part is states of matter. I told you. So solid molecules, I have told you, that is the most closely particles. You see, the most closely particles, and the least intermolecular force, means force of attraction among the molecule, is the highest. If the distance is least, then force is highest. Okay, obviously the distance is more, means force is less. So here intermolecular distance, that means distance amongst the molecules are the least, and that's why intermolecular force among the molecule is the highest. Whereas in the liquid, you see the molecules has some space, molecule has some space in it, so they have some space, and that's why intermolecular force of attraction is less in compared to the solid, but more than the gas. Okay, and intermolecular distance is less than the solid, but is more than the solid, but less than the gas. So what you have understood, in liquid intermolecular force of attraction is less than the solid, and distance is more than the solid. Okay, then if you come to the solid gaseous state, molecules are most far apart. It is the most far apart. You see, distance is more even than the liquid. So intermolecular force of attraction is the least, and intermolecular distance is the highest. Distance is the highest and force is the least. So this is the gaseous particles I have shown over here. Now what is solid? What is called solid? A solid is a definite, solid is a particles which has definite shape and size and definite volume, like iron, copper, etc. You see, the liquid has a definite volume but no definite shape. It takes the shape of the container. If you keep the 1 liter water in a bottle, it will take the 1 liter bottle shape. If you put in the floor, it will take the shape of the floor. It has no definite shape, but it has definite volume. Okay, a gas has neither definite shape nor definite volume. Okay, but all of these three, they have the definite mass. Okay, solid, liquid, gas, they have the definite mass. It takes the shape of the volume and the containing the vessels. Okay, obviously if you in this room, whatever the air present, we can pump it in a you can squeeze it in a bottle of bottle, and if you just open it, if you keep in the, again if you open the bottle, then it will take the shape of the room. That means it takes the shape of the container. Okay, so it is clear, solid, liquid and gas, they have the definite mass. Okay, here in solid, definite shape is there and definite volume. Okay, and liquid, obviously it has the definite mass. All solid, liquid and gas, they have the definite mass. Mass will remain same. Mass cannot change. We will learn later on, the mass can neither be created nor destroyed, but can be converted from one form to another form. That is called the law of conservation of mass. Now liquid also has a definite mass and definite volume, but no definite shape. It takes the shape of the container. And gas has a definite mass. It has neither definite shape nor a definite volume. Okay, no shape, no definite shape, no definite volume. Okay, so gas, whole room, whatever the gas, we can squeeze it in, can keep it in a bottle. Okay, so the next slide is, after solid, liquid, gas, I am telling you the plasma. Plasma, I told you, it is actually fourth state of matter, very important part. Plasma in ionic states actually. Matter present in the sun, fire, example of fire. What is fire? Fire is the one, this is actually plasma state. Okay, matter present in the sun, that is the plasma. You see, the fourth state of matter is highly ionized gas in which particles exist in super energetic and super excited state. We know about the fluorescent tubes and neon signs bulbs. The fluorescent bulbs contains the helium or some other gases. When electric current is passed through the gas, it produces glowing plasma having a characteristic color depending upon the nature of the gas. Plasma is produced in the sun and in the stars due to high temperature, okay. It is the presence of plasma that makes them glow, okay. Plasma is in ionic state, okay. Understand? It is highly ionized gas, okay. It is the fourth state of matter present in the sun, or example we can see the fire. Then it is the fifth state of matter, that is called the Bose-Einstein condensate. Indian scientists in 1920, the noted Indian scientist Satyendranath Bose, on the basis of the statistical calculations, he has given the concept of the fifth state of matter, okay. And in 1995, American scientists Cornell and Wyman finally created this new state of matter. If plasma are super hot and super excited the atoms in Bose-Einstein condensate, that we write shortly, Bose-Einstein condensate, are total opposites. They are super cold atoms, okay. Bose-Einstein condensates are super cold atoms. With the idea of the Albert Einsteins and Satyendranath Bose, okay, American scientists, they have found this one, okay, liquid crystals. That means after that computer, this digit, whatever you write in the computer and mobile, okay, that liquid crystals is the example Bose-Einstein condensate, okay, and then develop the computer, okay. Now next is firm ionic condensate, okay. Although it is not giving in your book, okay, normally it is not giving in your book, okay. So we know the fifth state of matter, okay, and here is the sixth state of matter also we say, okay. Firm ionic condensates are attained at temperature lower than the BEC, lower than the Bose-Einstein condensate. Firm ionic condensate are type of superfluid. What is called fluid? What is called fluid? The liquid and gases together called fluid, which can flow. We see the water can flow, okay, in a pipe, water flow when you pump, okay, and gas also they can flow. Liquid and gas together called fluid. Liquid and gas together called fluid. Fluid is equal to liquid plus gas. So is a superfluid possess fluid. That means fluid means what? I told you, liquid and gas together called fluid. This I have written over here. Okay. Possess fluid properties similar to those possessed by the ordinary liquids and gases, such as the lack of the definite shape and ability to flow responses to the applied force. Okay. That means firm ionic condensates are attained at the temperature, this is very important, temperature lower than the Bose-Einstein condensate. That means matter present lower than the Bose-Einstein condensate, that we say the firm ionic condensate, okay. Now after that some question answer sessions. So whatever you have learned, I will revise once again. So before that, few questions I am discussing, whatever we have discussed. Based on that, I have told you the particles, interparticles distance or intermolecular force of attractions I have discussed. So interparticle force are strongest. That means intermolecular force of attraction is the strongest in which? Solid, liquid, gas. I told you in the solid. So here question is the interparticle force are strongest in graphite, milk, oxygen and water. What is the answer? Students, you tell me. Okay. Now you see the graphite, milk, oxygen and water. We know water is liquid, okay, oxygen is gas, milk is liquid, and graphite, what is graphite? State, solid, liquid or gas? Graphite is solid. And we know the intermolecular force of attraction is the highest in solid, and that's why answer should be the graphite. Okay, graphite means I write. Okay, Greek word graphite means I write, and you see the pencil we write, na? We write, so that is the solid. So answer is graphite. Second question is, the change of state from solid to liquid is known as what? We know the solid, before answer is these questions, I have already discussed you about the interconversion of matter, okay, over here. Okay, the interconversion of matter, melting, freezing, boiling, condensation, sublimations. Okay, so this process I told you. Okay, and let us discuss over here. Question is question number 2. We know the solid, when you convert into liquid, again on heating, liquid to gas or vapor, and gas to solid, this we know the conversion of solid to liquid, that is, question is the change of state from solid to liquid is not what? This is also called melting, also called fusion. Okay, so our objective, already got it, it is called fusion. The conversion of solid to liquid is known as the fusions. Okay, so fusion also called melting, and liquid to solid, I'm just telling you, liquid to solid, that is called freezing. When you keep a bottle of water in a deep freeze, in our fridge, okay, then it's solidified, that is called freezing. And liquid to gas by heating, that is called vaporization. And when rain takes place, cloud, okay, rain occurs, that is the what? That is condensations. And conversion of solid to gas without changing, the conversion of solid to gas without changing the liquid state, that is called sublimation. Conversion of solid to gas, this is called sublimation. sublimation. And gas to solid, conversion of gas to solid, that is called deposition, without changing the liquid states. So this interconversion we know, so any kind of answer we can give it. Okay, so if the liquid change with the normal temperatures to gas, that is called evaporation, and if you heat it to the liquid and it changes to the gas state, then it is called what? Vaporizations. But in normal temperature, if the liquid, like say seawater, come to the vapor state, then we say the evaporations. Clear? So I repeat once again, the conversion of solid to liquid is called melting or fusion. Okay, liquid to solid, freezing. Okay, freezing and or solidification we can say. And liquid to gas, on heating, vaporations. Liquid to gas without heating, normal temperature, that is called evaporations. And gas to liquid, that is called condensations. Okay, by cooling, that is the condensation, like say rain occurs. Now solid to gas without changing the liquid state, that is called sublimations. And gas to solid, that is called depositions. The next third question is, plasma state is a neutral, ionic, fused, and all of this. Okay, I've told you the plasma, in the plasma that I've told you, that plasma is highly ionized gas. Okay, highly ionized gas. So obviously what should be the answer? You tell me. So you tell me. Hello, dear students, please tell me. It should be neutral, fused, ionic, all of this. I told you it is ionized gas. That means it is a ionic. Clear or not? Now next is the boiling point of water in Kelvin scales. You know that different types of temperature we have scale. We have the centigrade or Celsius scale, we have the Fahrenheit scales, or we have the Kelvin scales. Okay, we learn So Kelvin scales and centigrade scales relation is temperature is equal to T degree centigrade plus 273 Kelvin. Okay, so this is the relation. If the temperature in degree centigrade, if you add 273, then that will be the Kelvin scales, and that we write in K, or A we write absolute scales. So the boiling point of water is, we know that T degree centigrade, boiling point of water is 100 degree centigrade. 100 degree centigrade, if you write, that is the 100 degree centigrade plus 273, that is the 373 Kelvin. Okay, so answer is 373 Kelvin. So this is the relation between the Kelvin scales and the degree centigrade. Kelvin scale temperature is the Kelvin scale. Kelvin we will learn later on details. Also it is called absolute scales. We can give K or A. After the name of the scientist, it is the Kelvin, K, and absolute temperature it is also called minus 273. Considering that, this is the, we can say the A. Okay, so the boiling point of water is 100 degree centigrade. If you convert into Kelvin scales, then it will be the 373. Okay, now we see today this much. Again I will continue with that next day. Thank you all. Thank you for joining. Again we will discuss the next part next class. Thank you so much. I am ending this session.